In this video, I'm going to show you how you can build a function based on a parent function that undergoes a series of transformations. So I have a couple examples here. For 17, we're going to write the function that's created after the following transformations occur to the parent function y equals the square root of x. So we're going to kind of do these one at a time. So for the first one, the graph is going to be shifted up 4 units. So with the square root of x function, what that's going to do is going to take and just add on 4 on the outside of the function. And you can kind of graph these as you go. So I would graph y equals the square root of x and y1. I would graph y equals the square root of x plus 4 and y2 and make sure that it actually moves up 4. That's a really easy, quick and easy way to check and make sure you're building these the right way. Reflected about the x-axis, what that's going to do, it's going to put a negative on the outside of the square root sign, and then put a plus 4 on the outside. Again, graph it to check. And then the last one, and this one, shifted to the right 6 units. If you have y equals, that negative is still up front. To the right is going to put an x minus 6 underneath the radical, and a plus 4 on the outside. So all of those together, that would be your function. Let's take a look at one that's a little bit more challenging, the reciprocal function. So if we have y equals 1 over x, and we want to shift it down 3 units. I think that the reason why this one's just a little bit more difficult is because it's working with a function that really we don't have a lot of experience with yet in pre-calculus, so it's just a little bit of a stretch. If we want to shift it down 3 units, it's going to go a minus 3 after the 1 over x. So let's go ahead and color code that. If we're going to reflect it about the y-axis, that's going to put a negative. Now the thing that makes this one tricky is that there's no parentheses or square root sign or absolute value bar, so it's a matter of where that negative goes. So if you want to, you can kind of introduce your own parentheses around that x in the denominator just to kind of help out. But it should go right in front of the x if it's reflected about the y. And we still have that minus 3 on the outside. Again, you can kind of graph these in a series to check as you go. If you're going to stretch it vertically by 4, that's going to put a 4 on the outside. It's going to multiply it in. So there's a couple of different ways that could look. If I take this function and multiply it by 4, I could just leave the 4 out front there, which is perfectly fine. Or if you want to kind of clean it up a little bit, really it's 4 over 1, and when you multiply it in, it's going to give you, that 4 is going to go in the numerator, and we still have negative x in the denominator, and minus 3. And then, last but not least, we're going to shift it to the left 7. Now you have to be careful here, because we already have a negative in the denominator with the x. You want to make sure that this transformation stays true to how it's really going to work. So what I mean by that is, we have a negative, and if you want, you could put a negative 1 or just put a negative. And then to the left is going to be plus 7. So it's really going to look like that with the negative factored out. Minus 3 on the outside. Again, graph it to check. There's really, if you move it to the left 7 and you put in, if you don't put in extra parentheses, it's going to move it to the right. If you just have, if on the bottom if you have negative x plus 7. If you don't have them separated out. So just do a quick double check. And really, if you wanted to, you can simplify this to y is equal to 4 over negative x minus 7 minus 3. But I think for that one, really it's not necessary to simplify it out. And with this first factored way, it's easy to pick out and say, yep, there's a vertical stretch by 4, move down 3, reflect over y, and then since it's already in factored form, it got moved to the left 7. But really, either final answer is acceptable. I just think the one that's boxed up in pink is a little bit easier. Alright, so let's look at a couple. Alright, so for number 19, we have write the function that's created after the following transformations are applied to the graph of y equals the absolute value of x. So we're starting with the parent absolute value of x. We move it to the right 10. It's going to put an x minus 10 inside the absolute value bars. Down 3 units. So I'm going to put a minus 3 after it. Reflected over the y-axis. So now again we're going to have a negative that's going to be in front of the x. So when you write this, you want to keep your absolute value bars. I'm just going to go ahead and put a negative 1 and then x minus 10. You want to keep those separate. And we still have that minus 3 on the end. And then finally it gets stretched horizontally by a factor of 4. So you got to watch. If it said stretched vertically, we would just put a 4 in front of the absolute value bars and this function would be done. But the horizontal ones, remember, kind of behave the opposite. So if I'm going to put this back into the equation, I'm going to want to take the reciprocal of this first. So the reciprocal of 4 is 1 over 4. So that 1 over 4 is going to join this negative 1 here. So I can really just kind of combine them and write that as negative 1 over 4. X minus 10, close the parenthesis, close the absolute value bar, and minus 3 at the end. So that one's a little bit more difficult with the horizontal, but if you just kind of take your time and graph it as you go, hopefully you're getting better with these, so a little bit easier. And the last one, number 20, is supposed to be the step function. I don't know why the symbols didn't copy over, but that's going to be the step function. If you did this in your review and if that didn't come up on yours and you just did it with x, that's fine. But let's do it with the step function for this. So let's see here. We're going to shift it up 12. So it's going to go on the outside of our step function brackets. So plus 12 on the outside. Vertically stretched by a factor of 9. That's just going to tack a 9 out front. So save some space, put a 9 there. Reflected about the x-axis. So if you reflect it over x, that's going to put a negative in front of that 9. And let's see here. Shifted left 7. Now I'm going to go ahead and rewrite this. The left 7 is going to go inside with the x. So we have negative 9. So the reflection over x, the vertical stretch by 9, are greatest integer or step function brackets. X left 9 is going to put a plus, or left 7 rather, is going to put a plus 7 inside the bars. And we still have that plus 12 on the outside, can't forget about that. And then finally, it says shrunk horizontally by a factor of 2/5. So again, the horizontal stretch and shrinks, you want to take the reciprocal of them first. Whether you're looking at the function and you want to figure out what happened to it, or if you're trying to build the function, same way. So shrunk horizontally by a factor of 2/5. So this is going to become a 5 over 2. And again, we want to keep it separate from the left-right transformation, so put it in parentheses. Close your set brackets, plus 12. And that's the final equation. That one kind of threw in a lot of stuff, but you could graph this to check. Remember when you're going to graph the step function in your calculator, what you're looking for is, so it would be y equals, your calculator doesn't have those set brackets, those greatest integer step function brackets. So it would be, you would use int x. So for those of you that have the 84s or 83 calculators, what you would do is when you're in the y equals menu, you would hit the math button, go over to the num menu within the math menu. So math, over to num, and you're going to scroll down until you see int, and it should have a parentheses after it. You'll just hit enter on that, and then that will kind of take the place of your bars, and you'll see it'll be a little step function that when you graph it, it looks like this. If you have the TI Nspire, what I would recommend that you do is hit the catalog button. It's the button that looks like an open book on the right side of the calculator. And once you're in the full list of, you might kind of have to tab over to a different menu depending on what that brings up for you, but you want the list, the alphabetical list of all the different functions your calculator can do for you. I would hit the I button, which will take you down to the start of the I's, and scroll down until you also see INT, and that would be how you graph it on both of your calculators. So long story short, kind of build these as you go. I would graph it in your calculator to kind of visually double check that what you put in the function on paper matches what's written. So if it says it moves right, you actually moved it to the right, and so on and so forth. So that should kind of help out as you build these.